here really quickly, I just want to give you an overview of what Lab 2 is trying to do, and then we're going to move to work on Lab 2 individually, but I'll walk around and you can ask your neighbors questions. So first of all, remember in last unit, we covered some inference questions. The first one is Bayesian hypothesis testing, right? We're trying to figure out the posterior distribution of the unknown parameter in the posterior. So in this case, we used to do p beta in last unit, and now you can use p norm. Okay, so when you have this mu, only unknown parameters mu and sigma is known, then you can use p norm to get the exact solution. And if you're going to do approximation by Monte Carlo simulation, we used to do r beta, and now we use r gamma. Oh, sorry, r norm in this case. So there is that. And then when you go to credible interval, the exact solution we know is a normal distribution, so we can use q norm. We used to do q beta. Now you do q norm. And the other one is if you do obviously do Monte Carlo simulation, you do r norm, and then summarize from there. So that's another thing. The third one is prediction that we did. If you remember last time, whenever we're doing prediction, now you're also doing generation of random draw, so you do r norm in this case. Okay, so when you start working on Lab 2, you will see all of the instruction there, but I just want to give you an overview of how things are working. And lastly, we covered this as well. Remember last time in previous unit, we covered posterior predictive checking. That's to see how our predicted draws or how our predicted observations will look like the original sample. And we use that to evaluate whether our model is good or bad. Okay, so now we use r beta, used to do r beta, now we use r norm. So that's just a preview. And let me just show you, you can bring a computer now actually. And what I will show you is the, sorry. I'm going to share my screen. So Lab 2 again. Lab 2 is in our markdown file. So hopefully working with our Lab 1 can help you get some of this basic stuff working. But regardless, I walk around to help you with specific questions. But again, you will see that Lab 2, you will get it from Moodle, and then it's a markdown file, so you should open it in RStudio. And once you open it, you see that it's, there are a bunch of stuff written for you. Some of them are instructions, some of them are sample codes that you can use. So what you do is you can change the Lab 2 underscore your name, replace your name to your own name, because later you're going to use that to submit. And also make sure that the author line on line 16 should be your own name as well. Okay, so that's just to get things started. Let me quickly knit it here so you can see the output. Let's see. So let me just show this one. Okay. Yeah, so the output again, there's this template instruction, but then I gave you a summary of the Bayesian inference. In particular, we're dealing with the case that mu is unknown and then sigma is known. So I gave you the sampling model, which is the likelihood, and I also give you the prior distribution. In the end, in equation 3, I give you the final posterior distribution for mu. Okay, so you can follow that. And then the CE data example, by the way, you should download the CE sample 1 CSV from Moodle as well to work on Lab 2. And I copy and pasted the sample code that we covered in class of how to do computing, in particular the posterior mean and standard deviation for this normal mean parameter mu. And then, so these are all background information. And then you will see that there are 4 exercises for you to figure out, to make inference for this unknown mu. The first one is about hypothesis testing. I give you a hint. You can either use the p-norm function for the exact solution, or you can use approximation of the of the Monte Carlo. The second one is about count a credible interval. So you can either use exact solution or the R normal. The third one is about prediction. So I gave you some review of the prediction procedure. So remember, when you try to predict a new observation y, you should first of all make a prediction. You should first of all make a draw of mu from its posterior, right? And then you make a new prediction of y. And so that's what you equation 4 and equation 5 is about. So exercise 3 is asked you to make to simulate 1,000 predicted values and then make a plot. Okay, so use R, and I keep in mind that we set phi equals to 1.25 or sigma to be 0.9 because we assume that it's known. Okay, you can use these values. And the last one is about posterior predictive checking. I give you the instructions here. I think I probably just stop talking now so you can start working on it. And I will just walk around. And if there are any like common questions being asked, I will just address it in class and then show some sample code here. Okay. So yeah, take your time. I mean, this is probably more a little bit more difficult than the first lab because this one really walks through all of the different types of inference, and then you have to get into the script to know what you need to do through R to make a particular inference question doable. So I'm gonna stop here and I'll walk around to answer the question. Yeah, I want to mention one more thing. So on the screen right now, I put up the lecture slides from the previous unit where I show you like side by side how to get the exact solution and how to get the approximation from Monte Carlo, not for the current unit, but for the beta situation. So if you want, you can also open those to make sure that you know how to use, in this case, P beta and then R beta to answer the hypothesis testing question. But now for lab 2, you will have to do P norm and R norm. Okay, so this is just another thing that we went like pretty quickly, so maybe you didn't register in your head. But this is what we did before for hypothesis testing. And for credible interval, there is this slide here, that exact solution using the Q beta function, and then the approximation using the R beta. So in our case, it's going to be Q norm and then R norm. So these are the two, and there are other ones for prediction, for example, how you can use it. So I recommend you maybe open this slide as well if you're not super familiar with the process of doing it. Okay, so one more thing here is I noticed some of you are trying to knit the file, and then you might not get things right. So one thing about, so if you want, you can add on line, so between line 70 and line 71, add library, tidyverse. I didn't even have it, okay, tidyverse, So add that, because the read_CSV file is from that package. So if you see error message saying that we cannot find read_CSV, that's because the library tidyverse was not properly loaded. So the way to load it is you type library and then tidyverse. But if you have never installed it before, remember you go to console, you type install packages, and then parentheses quote tidyverse. So you can, so install packages is only installing once, but then whenever you're using the package, you should load it by typing library and then the name of the package. Okay, I will mention one more thing. Some of you are a little bit not sure. And I think this is probably the first time that we're loading data sets together with the file. So what you need to do is, remember you go to Moodle to click this csample1.csv. So you click it, it's going to download to your laptop. And what you need to do is you put the CSV file together with the markdown file in the same folder, so you can access it. So that's why some of you, when you're trying to run the chunks of code, it's saying that I cannot find C sample. So if I'm going to demo here using RStudio, what you do is you upload the CSV file that we just downloaded. In this case, I uploaded here.
Yeah, it was just.
And Also make sure that you know that working with R, you need to set the working directory in the correct folder, because otherwise you cannot find the particular data set or cannot find the other things. So the way to do working directory, on the top, you see that there's this section button. So you click section, and then you go here, set working directory, and it's choose directory. And for now, I'm in the correct folder. I'm in fall 2019 on my own file. But if your data sets as well as your R Markdown file is not saved in the right place, or like it's saved but not in the folder that you're working with, you have to go to find the working directory correctly and then click choose. And then once you run those files, it should be fine. So if you have issues of not finding a particular data set or similar things, let me know. But the thing that you need to do is you put all of your files in the same folder. And don't forget to set the working directory, because otherwise R and RStudio, they don't know that you're working in that working directory.
So since they're all false, the sum is 0. And